So I'm going to be giving a talk today about AI-generated GraphQL queries, and just a little bit about myself. You might have found me on the internet, hacking around on things, working on open source projects, and building GraphQL communities around the world. So AI-generated GraphQL queries. I'm going to go through a couple of steps today in this slides. I'm going to show you the library that we've generated. I'm going to show you how to take that to a production level using RAG. And then I'm just going to show you like some edge cases and some security vulnerabilities around generating your queries with AI. So it's going to be a bit codey today. I've got some TypeScript code, so hopefully I'm not going to scare some of you all off. But essentially, I'm going to be showing you a NPM library that we've been building that's going to let you generate some queries. So essentially, it starts like this. This is some TypeScript code, and I don't think the pointer works. But essentially, you start with your schema. So you can see that I've provided just a very basic schema into our GraphQL plain text client, or GQLPT. And then essentially what you can do is you can call this function called generate query and variables. And this is going to build a big prompt based off of the plain text that you give it and also the schema. And then it's going to send that to a large language model and then pass the response and then give it back to you something that looks a little bit like this. So essentially you can just say like, find all the users in my API, and it's going to give you the relevant query based off of the schema that you've got. There's two methods on the library. So you can call the generate query and variables, and you can also call the generate and send. And the generate send is just going to proxy it through to the API that you specify. So I have a demo. Let's just hopefully the demo gods play well with us. So I have this repo called Talk to GraphQL, which I highly suggest you go and check out after this talk. And I have it cloned down here. Zoom in. And in this repo, we have a schema. So this schema contains just basically some users and logins. It actually only has 2 queries on it, so it's quite short for demonstration purposes. And what I want to show you is how to configure your GQLPT client using this schema. So I've just like imported the schema from file, and then I'm just passing that raw GraphQL schema into GQLPT. And then I have like 2 functions that are called in this file. I have find all the usernames, which is essentially finding all the usernames. And I have find all logins by Alice as well. And I log them. So we can run that. And what that's going to do is it's going to take the type definitions that we gave it and the plain text query. And you'll see that Alice's logins, she has 2 logins. And the usernames are just 3 usernames. And I can change this around. So if we have a look at our local schema, we have a couple of other filters, like for example, a date filter in here. So maybe I want to find all the logins. If we just get rid of everything, and we'll say find all the logins between a date. So find all logins between just 2 random days, doesn't really matter. And then let's log that result. In fact, what I'll do is I'll pick 2 of the dates that are in our schema, and we have just like a bunch of dummy data up here. So I'll just pick like the 15th to the 17th. There we go. And let's run that. and you'll see that it's given us the 2 logins and it's generated the filter for us. Just to check out what that filter looks like, I can say generate query and variables, and we'll log that again. And you'll see that it's generated like some form of query that has the arguments inside of it, and it also has the variables for us as well. So it's just generated that query from the plain text prompt that we've given it. GQLPT also goes a step further. You can use local schemas and you can also use remote schemas. And in one of my examples here, I have a remote example. And instead of passing in the type definitions to our client, this time we're just passing in some headers and a URL. And this particular API that we're working with is the GraphQL, GitHub GraphQL API. So I'm talking, basically going to be able to speak plain text to GitHub. And in our remote example, I have 2 queries. The first one is find the latest issue on the GraphQL JS repo. And the second one is find the star count of the GraphQL JS repo. And then that's just going to resolve those for me. So I can run that. And it's going to take a little bit of time. And I'm going to dig into a little bit more about vectorizing and RAG later on in this talk. But the GitHub GraphQL schema is huge. It's maybe 300 entities inside of it. And so each time we run these functions, we're essentially going to have to send the schema along to the large language model each time with us. But I can run it anyway, and you'll see that it takes a long time, and it will prove to you why we might need some vectorization later on in this talk. Whenever that runs, it will run. Here we go. So that the latest issue on the GraphQL JS repo was something, maybe if we can find it, the body, CLA bot is there. But just to confirm that this like actually works, like GraphQL JS. Oh, GraphQL JS. Let's see that. Is it? Was it a pull request? Closed. Say again.
It would be a comment I expect on a pull request.
Let's have a look. Oh yeah, it's a comment on an issue. Let's have a look what we're seeing and how we could.
At the bottom of the body.
Yeah. Well, the star count will be somewhere close. I mean, they do round up the star count in the UI. So what does it say there? And what does it say there? Okay. I'm not sure exactly what we're seeing here. It seems like a really weird issue. Like the title is that. So I'm not sure what that is. Maybe a bug. We'll just gloss over it. Anyway.
It could be one of these GitHub bots that have been plaguing us recently. GitHub doesn't let you see it, so I'm surprised it comes through the API.
Oh, there you go. Okay, so we've had a little demo about GQLPT. You can install it from npm. Let's just dig into a little bit about how it works. And as I said, essentially it just builds one big massive prompt and then sends it to the large language model. And it looks a little bit like this. So you essentially inject the type definitions that you have, and then you inject the plain text, and then just some query generation rules. So in our open source repository, we have just like a bunch of query generation rules that you can add stuff to, and it will just get appended to each query. The type definitions, we compress them, because essentially if you have a very large schema, we're going to go over a lot of the character limits of these large language models. So we just basically get rid of all the white space. There's not really much we can do there at this time. The plain text, again, we just inject that into the prompt. but the library actually has some caching in there for you as well. So you can cache the responses, and the second time that you run the query, it's going to be a lot faster for you. And finally, just all the rules. So these aren't like the real rules, and you can go and check out all the rules that we have on the GitHub repo. But we just like append these to the prompt and then send it along to the large language model. So, you know, like use variable names, use fragments, or define the variables. We had some issues with subgraphs recently, so we just added some rules for traversing the subgraphs in the correct way. And then we just pass the response. But you're probably thinking, you know, it's just a plain text string. So you're not really going to be able to get any TypeScript inference from that plain text string. And this is where GQLPT CLI comes in. So the CLI will essentially scan your code for the generate and send methods. And if that exists, it's going to actually generate the TypeScript types, and it's also going to generate the query for you at build time. So that at runtime, you're just reading from disk, and it's not even talking to the large language model. And as I said, what it does is it looks for the string using static analysis, and then it will actually write the types to your node modules directory. And I can show you that. So I have my local example. Let me just get rid of everything. Okay, so we have our local example, and what you notice is that, you know, when we find all the usernames, there's no response type, and that makes sense because it's like a random plain text string that we don't know anything about. But in the package.json of this demo repo, you'll see that there's a generate command here, and it just runs npx GQL CLI, and it gives it like the location, which is our local file, and then the schema. And so I'm going to run that and bring up the local file. Let me just get rid of everything. So local. And now if I come and hover over this, you'll see that, you know, all of the response for all of the usernames actually has a type, and the same for the logins for Alice as a type. And the way that that does that is if I go to the node modules folder, and in the build, you'll see that there's a types TS file, and basically it creates like a map of the plain text query, and then also the TypeScript type beside it as well. And alongside these types, it also generates basically like a query cache, essentially. So you can just like build your GQLPT instance at build time, and then at runtime, it's just going to read these static queries from disk. And just to show you working on a larger scale API, we can also generate for the remote API. So this is the GitHub API. So I just run the same script, but for remote. And it may take a second because it has to send the entire GitHub schema to the large language model. Didn't take too long. But you'll see, find the latest issue of the GraphQL.js repo. You'll see that now it also gives us like the correct types. So basically, any GraphQL API that you can come along with, it will generate the queries and the types for you. And this one as well. There. So that is the CLI, the client and the CLI. And now to some of the juicy bits, which is the schema size. You know, if we're working with the GitHub GraphQL API, as I said, it's 300 entities big. We're quickly going to be consuming our tokens on whichever large language model we're using. Not only that, it's incredibly slow. This is just like a snapshot of the GitHub API, and you can see that it's already very big. And so there's a solution to this in the AI space, and this is called vectorized embeddings and RAG. And essentially what we can do is we can take our GraphQL schema and we can visit it and we can store it in a vector store. For the purposes of this demonstration, I'm going to show you how to use Neo4j. And essentially you create a binary representation of each type in your GraphQL schema, and then you store them in a graph. And then when you want to search for a particular query, you essentially give it the plain text string, which is in the top left corner. You use some Cypher, the query language from Neo4j, and you use their graph data science libraries. And it will essentially compare the vector of the plain text string against all of the vectors that you already have in your database. So you can see here in the highlighted in yellow that from finding all of the usernames, before I actually talk to GQLPT, I'm going and grabbing a subset of the schema that's relevant to my query. Then once you have that subset, you can basically pass this directly into GQLPT as you would just a normal type definitions, normal schema, but it's going to be maybe a fraction of the size because you've already leveraged your vector store to reduce the size of that schema. And I can just show you like what that looks like. I vectorized, it takes a long time to vectorize large schemas. And I was playing around earlier, uploading the schema that we have. And I do recommend you go to this repository if you're interested afterwards. But this is how we upload. We visit the schema, and then we basically create like some vectors and then create relationships in the database. And I have something here in Neo4j. If I just return everything, you'll see that this is like our demo schema, but vectorized in Neo4j. And you'll see that somewhere in here there is actually a query. So you'll see here we have like users and logins. And there's a very particular property on each node, which is the vector, which is like this huge binary form here. And what we do is we search the vector store for our plain text string, and then it will automatically compare the binary representation of the plain text string against all of the vectors in the database to see what's similar. And then in the query side of things, you basically match the nodes that are similar to your plain text query. And then I'll go over this, but you essentially create like a partial schema and then pass it directly into GQLPT client, and then that sends it off to your large language model, no problem. Okay, so you've learned kind of what is GQLPT, how to download and install the client, how to generate types, and how to take, generating GraphQL queries to production level with AI. So thank you very much for listening, everybody. I hope you enjoyed my talk.